The infinite puzzle. To stand at the edge of an endless desert is to confront infinity, not merely as a concept, but as a visceral experience. Imagine the horizon stretching infinitely before you, unbroken and eternal, each step forward revealing yet another expanse that seems to stretch further still. It is a landscape without boundaries, a realm where distance loses its meaning. Now, imagine that same infinity, not confined to the external world, but mirrored within your own mind. A labyrinth of questions without answers, riddles that loop back on themselves, ideas so vast they defy comprehension. This is the essence of paradoxes, infinite puzzles that challenge the very fabric of our understanding. Welcome to the ultimate list of paradoxes that break your mind to sleep to, a journey into the strange and beautiful contradictions that lie at the heart of existence. Tonight, we will explore 12 paradoxes and concepts designed to stretch your imagination, question your assumptions, and perhaps even lull you into peaceful slumber. These are not mere intellectual exercises. They are windows into the ineffable mysteries of reality itself. They invite us to peer beyond the veil of ordinary perception, to grapple with the limits of language, reason, and perception, and to discover glimpses of truths that transcend conventional understanding. Paradoxes have long captivated the human imagination. From ancient philosophers pondering free will to modern scientists grappling with quantum mechanics, these enigmatic loops of logic have shaped humanity's quest for meaning. At their core, paradoxes are more than intellectual puzzles. They are cracks in the foundation of logic, fissures through which deeper truths about how our minds work and don't work are revealed. They force us to confront the boundaries of what we can know, think, or consider the nature of paradoxes themselves. A paradox arises when two seemingly contradictory statements or ideas coexist, each valid in its own right, yet irreconcilable when placed side by side. For example, how can something be both finite and infinite? How can time move forward while simultaneously looping back on itself? Such contradictions defy resolution, creating a tension that challenges our most fundamental assumptions about reality. Yet, this very impossibility is what makes paradoxes so compelling. They reveal the limitations of human cognition, exposing the gaps between what we perceive and what truly is. What makes paradoxes so captivating is their ability to break conventional thinking. They remind us that the world isn't always as straightforward as it seems, that sometimes two opposing truths can coexist, or that what appears impossible might actually be true. Take Zeno's famous paradox of motion, for instance. According to Zeno, if you were to walk across a room, you would first need to cover half the distance, then half of the remaining distance, and so on ad infinitum. Logically, this suggests that motion is impossible, as you would never reach your destination. And yet, here we are, moving effortlessly through space every day. The paradox forces us to reconcile the abstract with the tangible, challenging us to rethink the nature of continuity and change. These contradictions aren't just academic curiosities. They shape our lives in profound ways. Consider the moral dilemmas posed by paradoxes like the trolley problem. Should you sacrifice one life to save 5 others? The answer depends on whether you prioritize utilitarian outcomes or individual rights. Yet neither choice feels entirely satisfactory. Similarly, technological advancements often hinge on resolving paradoxical challenges. How do we create machines smarter than ourselves without losing control over them? Each paradox serves as a mirror, reflecting not only the intricacies of the external world, but also the complexities of our inner selves. Moreover, paradoxes offer a unique form of solace. In a world increasingly defined by certainty and efficiency, they remind us of the beauty of uncertainty, the idea that some questions may never have definitive answers. This realization can be liberating, freeing us from the pressure to solve every problem or understand every mystery. Instead, paradoxes invite us to embrace ambiguity, to find wonder in the unknown, and to cherish the act of questioning itself. After all, it is in the pursuit of answers, rather than their attainment, that we often discover the greatest insights. Paradoxes also serve as bridges between disciplines, connecting fields as diverse as philosophy, mathematics, physics, and literature. They transcend traditional boundaries, offering a common language through which disparate ideas can converge. Consider the intersection of quantum mechanics and metaphysics, where Schrödinger's cat blurs the line between observer and observed, raising questions about the role of consciousness in shaping reality. Or consider the ethical implications of artificial intelligence, where the singularity hypothesis challenges us to rethink the nature of sentience and autonomy. In each case, paradoxes act as catalysts for interdisciplinary dialogue, fostering collaboration and innovation. Philosophically, paradoxes invite reflection on the nature of truth itself. Is truth absolute, or does it depend on perspective? Can multiple truths coexist, even if they appear contradictory? These questions resonate deeply with humanity's ongoing struggle to reconcile subjectivity with objectivity, intuition with evidence, and faith with reason. By engaging with paradoxes, we cultivate a mindset of openness and curiosity, embracing the complexity of existence rather than seeking to simplify it. Scientifically, paradoxes push the boundaries of inquiry, demanding innovation and creativity. They challenge researchers to develop new frameworks, theories, and methodologies capable of addressing problems that resist conventional solutions. For example, Einstein's theory of relativity emerged in part from his efforts to resolve apparent paradoxes in Newtonian mechanics, such as the behavior of light and the nature of simultaneity. Similarly, advances in quantum computing stem from attempts to navigate the counterintuitive principles of superposition and entanglement. Each breakthrough underscores the power of paradoxes to inspire progress, even as they expose the limits of current knowledge. Ultimately, paradoxes remind us of the audacity of human curiosity, the fact that we, fragile creatures born of stardust, dare to ask such monumental questions in the first place. They challenge us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Whether exploring the infinite possibilities of space-time or pondering the nature of free will, paradoxes invite us to embrace the boundless potential of thought itself. Take a moment to reflect on this. If infinity stretches endlessly in all directions, where do you begin? And if there's no beginning, does that mean anything truly matters? Let's start our exploration with one of the oldest and most profound philosophical conundrums, the paradox of free will. The paradox of free will. To grapple with the paradox of free will is to confront one of humanity's most enduring and profound dilemmas. At its core lies a tension that has shaped philosophy, science, and ethics for centuries, a tension between determinism and the belief in human agency. Determinism, the idea that every event has a cause and unfolds according to fixed physical laws, suggests a universe where everything is preordained. If this is true, then every decision you make, from what you had for breakfast to the career path you chose, was determined long before you were born, perhaps even at the moment of the Big Bang itself. Yet, subjective experience tells us otherwise. We feel as though we are making choices freely, weighing options, and acting on our desires. This contradiction forms the essence of the paradox of free will. How can we reconcile the apparent predictability of nature with the deeply ingrained intuition that we are free agents? The roots of this paradox stretch back to ancient times, when philosophers first began questioning the nature of causality and human autonomy. Thinkers like Aristotle pondered whether actions were driven by fate or personal choice, while later luminaries such as Immanuel Kant sought to bridge the gap between freedom and necessity. Over time, the debate evolved, incorporating insights from physics, neuroscience, and psychology. Modern interpretations have introduced nuanced perspectives, such as compatibilism, which posits that free will and determinism are not mutually exclusive, but can coexist within certain frameworks. Despite these efforts, the paradox remains unresolved, continuing to provoke deep reflection and spirited discourse. At the heart of the issue is the question of causation. If the universe operates according to deterministic principles, then every action, thought, and emotion is the inevitable result of prior conditions. Consider the analogy of a domino chain. Once the first domino falls, the trajectory of the entire sequence is set in motion, with each subsequent tile toppling inexorably due to forces beyond its control. In this view, human behavior follows similar logic. Our thoughts, feelings, and decisions are products of neural processes governed by biology, chemistry, and physics, all of which obey immutable natural laws. From this perspective, free will appears to be an illusion, a comforting narrative constructed by the mind to mask the underlying mechanistic reality. Yet, the subjective experience of choice resists such reductionism. When faced with a decision, we often deliberate, weigh pros and cons, and ultimately select one option over another. This process feels intentional, as though we are exercising agency rather than passively following predetermined scripts. For example, imagine standing at a crossroads, deciding whether to turn left or right. You might consider factors like time constraints, personal preferences, or potential outcomes before making your choice. To dismiss this experience as illusory seems counterintuitive, if not outright absurd. After all, if free will is merely a construct of the brain, why does it feel so real? And what implications does this have for our understanding of morality, accountability, and identity? Philosophers have proposed various solutions to navigate this tension. Compatibilists argue that free will and determinism are not inherently incompatible. According to this view, free will does not require absolute independence from external influences. Rather, it entails the ability to act in accordance with one's desires and intentions without coercion. In other words, even if our choices are shaped by prior causes, we can still be considered free, as long as those choices align with our internal motivations. This approach preserves the notion of moral responsibility, allowing individuals to be held accountable for their actions while acknowledging the influence of external factors. On the opposite end of the spectrum, hard determinists reject the existence of free will altogether, asserting that all events, including human actions, are dictated by causal chains beyond our control. From this standpoint, concepts like guilt, blame, and praise lose their traditional meanings, as no one can truly be said to choose anything. Conversely, libertarians advocate for the reality of free will, arguing that humans possess a unique capacity for self-determination that transcends physical laws. This perspective emphasizes the importance of individual autonomy, but struggles to explain how non-deterministic freedom could arise within a deterministic framework. The implications of the paradox extend far beyond philosophical debates, seeping into nearly every facet of human life. One of the most unsettling questions it raises concerns morality. If free will is an illusion, does morality lose its meaning? Consider the concept of accountability. Legal systems, ethical frameworks, and social norms are built on the assumption that people are responsible for their actions. Punishments, rewards, and judgments hinge on the belief that individuals have the power to choose between right and wrong. But if our decisions are predetermined, then holding someone accountable becomes problematic. Are we punishing them for something they had no control over? Or are we simply responding to the inevitable consequences of prior causes? This challenge also reverberates through fields like neuroscience and artificial intelligence. Advances in brain imaging technology have revealed correlations between neural activity and decision-making, suggesting that many of our choices may be unconscious and automatic rather than deliberate. These findings lend credence to deterministic models of behavior, raising questions about the extent to which humans genuinely exercise agency. Similarly, the development of AI systems capable of autonomous decision-making complicates traditional notions of responsibility. If a machine makes a harmful decision, who or what is to blame? The programmer, the algorithm, or the system itself? As technology continues to blur the lines between human and machine cognition, the paradox of free will takes on new urgency. Moreover, the paradox invites reflection on the nature of identity and selfhood. If our actions are predetermined, what does it mean to be an individual? Are we simply puppets dancing to the tune of unseen forces, or do we retain some kernel of autonomy that defines us as unique beings? These questions resonate deeply with humanity's ongoing struggle to reconcile subjectivity with objectivity, intuition with evidence, and faith with reason. By engaging with the paradox of free will, we cultivate a mindset of openness and curiosity, embracing the complexity of existence rather than seeking to simplify it. Scientifically, the paradox pushes the boundaries of inquiry, demanding innovation and creativity. It challenges researchers to develop new frameworks, theories, and methodologies capable of addressing problems that resist conventional solutions. For example, quantum mechanics introduces elements of randomness and unpredictability into the fabric of reality, offering a potential escape hatch from strict determinism. Some theorists speculate that quantum indeterminacy could provide a mechanism for genuine free will, allowing for spontaneous deviations from causal chains. While speculative, Such ideas underscore the power of paradoxes to inspire progress, even as they expose the limits of current knowledge. Ultimately, the paradox of free will serves as both a mirror and a magnifying glass, reflecting our deepest fears and aspirations while amplifying the mysteries that define our existence. It challenges us to embrace ambiguity, to find inspiration in the unknown, and to continue seeking answers even when certainty seems elusive. By probing the depths of this enigma, we not only deepen our understanding of the cosmos, but also illuminate the boundless potential of human curiosity. If free will feels slippery, wait until we dive into a paradox that literally bends time itself. Is the future set in stone, or can we rewrite history? Let's explore the grandfather paradox next. The grandfather paradox. To explore the concept of time travel is to step into a realm where logic bends and reality itself seems to unravel. Among the many mind-bending conundrums that arise from this speculative idea, none is more perplexing or more captivating than the grandfather paradox. Imagine standing at the threshold of history, armed with the ability to traverse the rivers of time. Now, picture yourself stepping into the past, perhaps with good intentions, only to accidentally prevent your grandfather from meeting your grandmother. In doing so, you erase your own existence. But here lies the crux of the paradox. If you were never born, how could you have traveled back in time to interfere in the first place? This circular reasoning creates a logical knot that defies resolution, challenging not only our understanding of causality, but also the very fabric of reality. At its core, the grandfather paradox exposes the fragility of one of humanity's most fundamental principles, the notion that cause precedes effect. Causality, the idea that every event has a preceding cause, is a cornerstone of classical physics and everyday experience. It provides structure and predictability to the universe, allowing us to make sense of the world around us. Yet, when time travel enters the equation, this principle begins to falter. The paradox forces us to confront the unsettling possibility that time may not behave as linearly or consistently as we assume. What happens when an action in the past disrupts the chain of events leading to the present? Does it create a ripple effect that erases entire timelines, or does it give rise to alternate realities? The implications of the grandfather paradox extend far beyond mere theoretical speculation. They invite us to reimagine the nature of time itself. One possible explanation for resolving the paradox lies in the multiverse theory, a hypothesis suggesting that every decision or event spawns a new, parallel universe. In this framework, traveling back in time and altering the past would not erase your original timeline, but instead create a branching reality. For instance, preventing your grandfather from meeting your grandmother might result in a universe where you do not exist, while your original timeline remains intact. This interpretation offers a tantalizing solution to the paradox, preserving both causality and free will by positing infinite possibilities within an ever-expanding multiverse. Yet, the multiverse theory raises profound questions of its own. If every choice spawns a new universe, how do we define identity across these divergent realities? Are you still you if countless versions of yourself exist simultaneously, each shaped by different circumstances and decisions? Moreover, the sheer scale of such a multiverse challenges our capacity to comprehend infinity. stretching the limits of human imagination. While this hypothesis provides a potential escape from the paradox, it also opens the door to even greater mysteries about the nature of existence. Another intriguing possibility is the concept of self-correcting timelines. According to this idea, time itself possesses an inherent mechanism that prevents paradoxes from occurring. Returning to our earlier example, imagine attempting to prevent your grandparents' meeting only to find inexplicable forces thwarting your efforts. A misplaced letter, a chance encounter, or some other unforeseen twist of fate ensuring their union. In this scenario, time acts as a closed loop, immune to disruptions that would otherwise unravel its continuity. Such a model aligns with deterministic views of the universe, where every event is predetermined and immutable. However, it also undermines the notion of free will, suggesting that our actions are ultimately irrelevant within the grand scheme of things. The philosophical ramifications of the grandfather paradox are equally profound. It forces us to reconsider the relationship between agency and consequence, questioning whether our choices truly matter in a universe governed by immutable laws. If time is self-correcting, then morality becomes a moot point. Our actions, no matter how well-intentioned, cannot alter the course of destiny. Conversely, if alternate timelines exist, then ethical responsibility takes on a new dimension, as every decision carries the weight of creating entirely new worlds. These considerations blur the line between science fiction and existential inquiry, inviting reflection on what it means to live meaningfully in a cosmos teeming with possibilities. Scientifically, the paradox serves as a catalyst for exploring the boundaries of theoretical physics. Researchers have long speculated about the nature of time, seeking to reconcile the deterministic principles of general relativity with the probabilistic quirks of quantum mechanics. Some theories propose that time loops, closed time-like curves, could theoretically exist under certain conditions, allowing for backward time travel without violating causality. Others suggest that time may be fundamentally nonlinear, existing as a multidimensional tapestry rather than a straight line. While experimental evidence remains elusive, these ideas continue to fuel scientific inquiry, inspiring breakthroughs in fields ranging from cosmology to artificial intelligence. Moreover, the grandfather paradox has left an indelible mark on popular culture, permeating literature, film, and television. From H.G. Wells's The Time Machine to modern blockbusters like Back to the Future, storytellers have grappled with the paradox's implications, using it as a narrative device to explore themes of fate, identity, and redemption. These works often reflect societal anxieties about technology and progress, casting time travel as both a source of wonder and a harbinger of chaos. By engaging with the paradox through storytelling, audiences gain a deeper appreciation for its complexity, transforming abstract concepts into emotionally resonant experiences. Philosophically, the paradox invites reflection on the nature of truth itself. Is time absolute, or does it depend on perspective? Can multiple truths coexist, even if they appear contradictory? These questions resonate deeply with humanity's ongoing struggle to reconcile subjectivity with objectivity, intuition with evidence, and faith with reason. By engaging with the grandfather paradox, we cultivate a mindset of openness and curiosity, embracing the complexity of existence rather than seeking to simplify it. Ultimately, the grandfather paradox serves as a mirror, reflecting both the brilliance and the limitations of human knowledge. It reminds us of the sheer audacity of our curiosity, the fact that we, fragile creatures born of stardust, dare to ask such monumental questions in the first place. And it challenges us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Whether viewed through the lens of science fiction or rigorous academic inquiry, the paradox underscores the boundless potential of thought itself. Speaking of bending reality, let's turn our attention inward. What if the very act of observing something changes it forever? Prepare to unravel Schrödinger's cat and the strange world of quantum mechanics. Schrödinger's cat. To delve into the enigmatic world of quantum mechanics is to step into a realm where reality itself seems to dissolve into ambiguity. At the heart of this strange and counterintuitive domain lies one of its most iconic thought experiments, Schrödinger's cat. Conceived by Austrian physicist Erwin Schrödinger in 1935, this paradox was designed not to explain quantum mechanics, but rather to highlight its absurdities. It poses a deceptively simple scenario that challenges our understanding of existence, observation, and the very nature of reality. Imagine placing the cat inside a sealed box along with a radioactive atom, a Geiger counter, a vial of poison, and a hammer mechanism. If the radioactive atom decays, the Geiger counter triggers the hammer to break the vial, releasing the poison and killing the cat. However, if the atom does not decay, the cat remains alive. According to the principles of quantum mechanics, until the box is opened and the system is observed, the atom exists in a state of superposition, both decayed and not decayed simultaneously. Consequently, the cat is neither alive nor dead, but suspended in a liminal state, existing in both conditions at once. This unsettling metaphor encapsulates the probabilistic nature of quantum reality, where particles can occupy multiple states until measured. At its core, Schrödinger's cat demonstrates the concept of superposition, a cornerstone of quantum mechanics that defies classical intuition. Superposition suggests that particles such as electrons or photons do not have definite properties until they are observed. Instead, they exist in a probabilistic haze of potential outcomes, represented mathematically by a wave function. Only when an observation or measurement occurs does the wave function collapse, forcing the particle into a single, definite state. In the case of Schrödinger's cat, the act of opening the box serves as the measurement, collapsing the wave function and determining whether the cat is alive or dead. While this thought experiment was originally intended as a critique of the Copenhagen interpretation of quantum mechanics, the idea that particles remain in superposition until observed, it has since become a powerful symbol of the peculiarities inherent in quantum theory. The implications of Schrödinger's cat extend far beyond the confines of theoretical physics, raising profound philosophical questions about the nature of reality and the role of the observer. One of the most intriguing debates centers on the relationship between consciousness and measurement. Does the act of observation require conscious awareness, or is it merely a physical interaction? If consciousness plays no role, then the collapse of the wave function could be attributed to any form of interaction. For instance, the Geiger counter detecting radiation. However, if consciousness is integral to the process, then reality itself becomes contingent upon perception, suggesting that the universe behaves differently depending on whether it is being observed. This notion blurs the line between subjectivity and objectivity, challenging the traditional view of an external independent reality. The philosophical ramifications of Schrödinger's cat are vast and multifaceted. On one hand, it invites us to consider the possibility that reality is fundamentally participatory, that our observations actively shape the world around us. This perspective aligns with certain interpretations of quantum mechanics, such as the relational interpretation, which posits that the properties of particles are defined only relative to specific observers. On the other hand, it raises unsettling questions about the nature of existence itself. If particles, and by extension, macroscopic objects like cats, can exist in multiple states simultaneously, what does it mean for something to exist at all? Are we living in a universe that is perpetually undecided, awaiting the gaze of an observer to crystallize into certainty? Moreover, Schrödinger's cat forces us to confront the limits of human cognition. Our brains are wired to perceive the world through the lens of classical physics, where objects have definite positions, velocities, and states. Quantum mechanics, however, operates according to entirely different rules, rules that defy logic and intuition. The paradox underscores the gap between how we perceive reality and how it actually functions at the smallest scales. It reminds us that the tools we use to make sense of the universe, language, mathematics, and sensory experience, are ultimately imperfect, incapable of fully capturing the strangeness of the quantum realm. Scientifically, the paradox continues to baffle physicists and philosophers alike, fueling ongoing debates about the foundations of quantum mechanics. Some researchers advocate for alternative interpretations, such as the many worlds interpretation, MWI, which proposes that every possible outcome of a quantum event actually occurs in separate branching universes. In this framework, when the box is opened, the universe splits into two parallel realities, one in which the cat is alive and another in which it is dead. While MWI offers a compelling resolution to the paradox, it introduces new complexities, such as the infinite proliferation of universes and the question of how these realities interact, or fail to interact, with one another. Other interpretations, such as decoherence theory, suggest that superpositions are not truly resolved through observation, but rather become entangled with their environment, effectively rendering them indistinguishable from classical states. These theories reflect humanity's relentless pursuit of understanding, even as they expose the depth of our ignorance. The cultural impact of Schrödinger's cat cannot be overstated. Beyond its scientific significance, the thought experiment has permeated popular culture, serving as a metaphor for uncertainty, duality, and the tension between opposing truths. It appears in literature, film, art, and philosophy, often used to explore themes of identity, morality, and existentialism. For example, in speculative fiction, characters might grapple with the consequences of their actions in a multiverse where every choice spawns a new reality. In visual art, the image of a suspended cat, neither alive nor dead, has become a powerful symbol of ambiguity and paradox. By engaging with Schrödinger's cat through creative expression, audiences gain a deeper appreciation for its complexity, transforming abstract concepts into emotionally resonant experiences. Philosophically, the paradox invites reflection on the nature of truth itself. Is reality absolute, or does it depend on perspective? Can multiple truths coexist, even if they appear contradictory? These questions resonate deeply with humanity's ongoing struggle to reconcile subjectivity with objectivity, intuition with evidence, and faith with reason. By engaging with Schrödinger's cat, we cultivate a mindset of openness and curiosity, embracing the complexity of existence rather than seeking to simplify it. It challenges us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Ultimately, Schrödinger's cat serves as both a mirror and a magnifying glass, reflecting our deepest fears and aspirations while amplifying the mysteries that define our existence. It reminds us of the sheer audacity of human curiosity, the fact that we, fragile creatures born of stardust, dare to ask such monumental questions in the first place. And it challenges us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Whether viewed through the lens of science fiction or rigorous academic inquiry, the paradox underscores the boundless potential of thought itself. From the microscopic to the cosmic, let's zoom out and consider a question that haunts astronomers and dreamers alike. Where is everyone? Brace yourself for the Fermi paradox. The Fermi paradox. To gaze up at the night sky is to confront an overwhelming truth. The universe is vast, ancient, and teeming with potential. With billions of galaxies, each containing billions of stars and potentially even more planets, the statistical likelihood of extraterrestrial life seems almost inevitable. Yet, despite this staggering probability, humanity has yet to find definitive evidence of intelligent civilizations beyond Earth. This unsettling contradiction lies at the heart of the Fermi paradox, a question so simple in its formulation, yet so profound in its implications. Where is everybody? These four words, uttered by physicist Enrico Fermi during a casual lunch conversation in 1950, have since become one of the most enduring mysteries in science and philosophy. They encapsulate not only our longing to connect with the cosmos, but also the unsettling possibility that we may be profoundly alone, or worse, isolated for reasons we cannot yet comprehend. At its core, the Fermi paradox arises from a tension between two seemingly incompatible truths. On one hand, the sheer scale of the universe suggests that intelligent life should be abundant. Estimates based on the Drake equation, a framework designed to calculate the number of active, communicative, extraterrestrial civilizations, indicate that even under conservative assumptions, there could be thousands of advanced civilizations within our galaxy alone. On the other hand, decades of searching through radio telescopes, space probes, and observational astronomy have yielded no conclusive evidence of their existence. This silence, often referred to as the Great Silence, raises profound questions about the nature of intelligence, the longevity of civilizations, and humanity's place in the cosmos. The paradox invites us to consider a wide array of hypotheses, each attempting to explain why we have not yet encountered alien life. Some suggest that technological civilizations inevitably self-destruct, succumbing to nuclear war, environmental collapse, or artificial intelligence run amok. Others propose that advanced beings might deliberately isolate themselves, choosing to remain hidden either out of caution or indifference. Still others speculate that we may simply be looking in the wrong places or using the wrong methods, failing to recognize signs of intelligence that manifest in ways we cannot yet comprehend. Each hypothesis carries its own set of implications, challenging us to rethink not only the cosmos, but also ourselves. One of the most unsettling explanations for the Fermi paradox is the idea that technological progress inherently leads to self-destruction. Civilizations capable of developing interstellar communication and travel are also likely to possess the means to annihilate themselves, whether through warfare, ecological collapse, or unforeseen consequences of their own creations. This great filter hypothesis posits that there exists a critical barrier, either behind us, such as overcoming early extinction events, or ahead of us, that prevents most civilizations from surviving long enough to make contact with others. If the great filter lies ahead, it implies a grim future for humanity, suggesting that our technological advancements may ultimately seal our fate. Conversely, if the filter lies behind us, it offers a glimmer of hope, implying that we have already overcome one of the greatest hurdles to survival. Another possibility is that advanced civilizations deliberately avoid detection, either to protect themselves or to allow younger species like ours to evolve without interference. This zoo hypothesis envisions Earth as part of a galactic preserve, observed but untouched by more sophisticated beings. While this scenario provides a comforting explanation for the Great Silence, it also raises ethical questions about the responsibilities of advanced civilizations. Should they intervene to prevent suffering or extinction among younger species? Or does non-interference serve a greater purpose, preserving the natural evolution of life across the cosmos? These considerations blur the line between science fiction and moral philosophy, inviting reflection on what it means to coexist in a universe potentially shared by others. Alternatively, the absence of evidence may stem from fundamental limitations in our ability to perceive or interpret alien signals. Human technology is still in its infancy compared to the vast timescales of cosmic history, and our understanding of communication is rooted in human-centric assumptions. Aliens might communicate using methods entirely foreign to us, perhaps through neutrinos, gravitational waves, or forms of energy we cannot yet detect. They might also encode information in ways that defy our current comprehension, such as higher dimensional mathematics or quantum entanglement. In this view, the Fermi paradox reflects not the absence of extraterrestrial life, but rather the inadequacy of our tools and perspectives. Philosophically, the Fermi paradox forces us to grapple with existential questions about isolation, insignificance, and purpose. Are we truly alone in the universe? Or do we occupy a position so marginal that our existence goes unnoticed? If the former is true, then humanity bears an immense responsibility to preserve life, to explore the cosmos, and to ensure that our legacy endures amidst the void. If the latter holds, then our struggles, achievements, and aspirations take on a poignant fragility, reminding us of the fleeting nature of our presence in an indifferent universe. Either way, the paradox challenges us to find meaning in uncertainty, to embrace curiosity as a form of resilience, and to cherish the act of questioning itself. Scientifically, the Fermi paradox serves as a catalyst for innovation and exploration. It drives efforts to improve detection technologies, refine search strategies, and expand our understanding of astrobiology, the study of life's origins and distribution in the universe. Projects like SETI, Search for Extraterrestrial Intelligence, and initiatives to identify biosignatures on exoplanets reflect humanity's determination to answer Fermi's deceptively simple question. Even as these endeavors yield tantalizing clues rather than definitive answers, they underscore the importance of persistence and imagination in the face of uncertainty. Moreover, the Fermi paradox resonates deeply with humanity's collective psyche, tapping into themes of wonder, fear, and longing. It appears in literature, film, and art, often used to explore the tension between hope and despair, connection and isolation. For example, science fiction stories frequently depict first contact scenarios, ranging from peaceful exchanges to catastrophic conflicts, reflecting society's anxieties about encountering the unknown. Similarly, visual art often portrays the cosmos as both a source of inspiration and a reminder of humanity's smallness, capturing the paradoxical beauty of infinite possibility juxtaposed with profound solitude. By engaging with the Fermi paradox through creative expression, audiences gain a deeper appreciation for its complexity, transforming abstract concepts into emotionally resonant experiences. Ultimately, the Fermi paradox serves as both a mirror and a magnifying glass, reflecting our deepest fears and aspirations while amplifying the mysteries that define our existence. It reminds us of the sheer audacity of human curiosity, the fact that we, fragile creatures born of stardust, dare to ask such monumental questions in the first place. And it challenges us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Whether viewed through the lens of scientific inquiry or philosophical contemplation, the paradox underscores the boundless potential of thought itself. While searching for alien life, let's not forget the mysteries closer to home. What if the universe itself is just a simulation? Dive into the simulation hypothesis. The simulation hypothesis. To imagine the universe as a simulation is to peer into one of humanity's most provocative and unsettling ideas. What if everything we perceive, the earth beneath our feet, the stars above us, even the very essence of our thoughts and emotions, is not real but rather an intricately designed construct? This notion, known as the simulation hypothesis, challenges the foundations of reality itself, inviting us to question whether we are living in base reality or merely characters in an advanced virtual environment. Popularized by philosopher Nick Bostrom and inspired by rapid advancements in technology, this hypothesis suggests that the physical world we experience could be nothing more than a sophisticated simulation, akin to a video game or virtual reality program. It forces us to confront profound questions about the nature of consciousness, free will, and the origins of life. At its core, the simulation hypothesis posits a deceptively simple yet profoundly disorienting premise. If it is possible for a civilization to create a hyper-realistic simulation, and if they choose to run many such simulations, then statistically speaking, it is far more likely that we are simulated beings rather than the original creators. To grasp this concept, consider the exponential progress of technology over the past century. Today, we can craft immersive virtual worlds with stunning detail, offering experiences so lifelike that they blur the line between fiction and reality. Video games, augmented reality, and artificial intelligence have already demonstrated the potential for creating complex, interactive environments. If this trend continues, future civilizations may possess the capability to simulate entire universes, complete with sentient beings who believe they are real. In such a scenario, what we perceive as reality might be nothing more than lines of code running on a cosmic supercomputer. This idea is not merely speculative, it is rooted in logical reasoning. Nick Bostrom's seminal argument outlines three possibilities. 1. Almost all civilizations at our level of technological development go extinct before reaching the ability to create ancestor simulations. 2. Civilizations capable of creating such simulations choose not to do so. Or 3. We are almost certainly living in a simulation. If the first two options are false, then the third becomes overwhelmingly probable. This statistical inevitability raises startling implications, suggesting that layers upon layers of simulated realities could exist, each indistinguishable from the last. The recursive nature of this hypothesis mirrors ancient philosophical debates about divinity and creation, reframing them through the lens of modern science and technology. The implications of the simulation hypothesis are staggering, forcing us to grapple with deeply existential questions. If we are living in a simulation, does anything we do truly matter? Are our emotions, relationships, and achievements genuine expressions of free will, or are they pre-programmed responses dictated by the rules of the simulation? These uncertainties challenge the very fabric of human existence, shaking the pillars of purpose and identity. Imagine dedicating your life to a cause only to discover that your efforts were scripted, your triumphs predetermined, and your struggles meaningless within the confines of the program. Such a revelation would cast doubt not only on the significance of individual actions, but also on the collective endeavors of humanity as a whole. Moreover, the hypothesis blurs the line between creator and creation, raising fundamental questions about the nature of divinity and the origins of the cosmos. If we are simulated beings, who or what is responsible for our existence? Could our simulators themselves be part of another simulation, creating an infinite regress of nested realities? This recursive structure echoes ancient myths and religious narratives, where gods create worlds and beings who, in turn, seek to understand their own origins. Yet, unlike traditional accounts of creation, the simulation hypothesis places humanity within a framework of technological determinism, reframing the divine as an advanced intelligence operating beyond our comprehension. This perspective invites reflection on whether our creators are benevolent architects, indifferent observers, or something altogether alien. Ethically, the simulation hypothesis raises troubling questions about consent and autonomy. If we are indeed simulated entities, do we have any rights or agency within the system? Are we mere tools or experiments existing solely to fulfill the purposes of our creators? These considerations echo contemporary debates surrounding artificial intelligence and the moral responsibilities of those who design and deploy intelligent systems. For instance, if a simulated being develops self-awareness, does it deserve ethical consideration akin to that granted to sentient beings in base reality? Or are we, like characters in a story, bound by the narrative constraints imposed by our creators? These dilemmas highlight the fragility of autonomy and the precariousness of existence in a world potentially governed by external forces. Scientifically, the simulation hypothesis inspires both skepticism and curiosity. While it remains unprovable with current technology, some researchers propose methods to test the theory. For example, physicists have speculated about detecting glitches or anomalies in the fabric of reality, patterns that might betray the underlying code of the simulation. Others suggest searching for evidence of pixelation at the smallest scales of space-time, akin to the resolution limits of digital images. However, critics argue that the hypothesis is inherently unfalsifiable, rendering it speculative rather than scientific. Despite these objections, the simulation hypothesis serves as a powerful thought experiment, challenging us to think critically about the nature of reality and our place within it. It underscores the importance of humility, reminding us that our understanding of the universe is always provisional, shaped by the limitations of our senses and intellect. Philosophically, the hypothesis invites reflection on the nature of truth itself. Is reality absolute, or does it depend on perspective? Can multiple truths coexist, even if they appear contradictory? These questions resonate deeply with humanity's ongoing struggle to reconcile subjectivity with objectivity, intuition with evidence, and faith with reason. By engaging with the simulation hypothesis, we cultivate a mindset of openness and curiosity, embracing the complexity of existence rather than seeking to simplify it. It challenges us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Whether viewed through the lens of science fiction or rigorous academic inquiry, the hypothesis underscores the boundless potential of thought itself. Ultimately, the simulation hypothesis serves as both a mirror and a magnifying glass, reflecting our deepest fears and aspirations while amplifying the mysteries that define our existence. It reminds us of the sheer audacity of human curiosity, the fact that we, fragile creatures born of stardust, dare to ask such monumental questions in the first place. And it challenges us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Whether viewed through the lens of scientific inquiry or philosophical contemplation, the hypothesis underscores the boundless potential of thought itself. If the idea of living in a simulation feels disorienting, prepare to dive into another paradox that defies logic and intuition. Zeno's paradoxes. How can motion exist if space is infinitely divisible? Let's explore the mind-bending riddles of infinity next. Zeno's paradoxes. To delve into the realm of Zeno's paradoxes is to step into a world where logic bends and intuition falters. These ancient thought experiments, devised by the Greek philosopher Zeno of Elea in the 5th century BCE, challenge our understanding of motion, time, space, and infinity. At first glance, they seem absurd, contradicting the everyday experience of walking across a room or watching a runner overtake another. Yet, beneath their deceptive simplicity lies a profound exploration of the tension between the discrete and the continuous, revealing ambiguities that have puzzled thinkers for millennia. Zeno's paradoxes force us to confront the limits of human perception and reasoning, exposing the fragile boundary between abstract mathematics and tangible reality. At the heart of Zeno's arguments lies the concept of infinity, a notion both beguiling and bewildering. Consider the dichotomy paradox, one of his most famous formulations. It posits that before reaching a destination, one must first traverse half the distance. But before reaching that halfway point, one must cover half of the remaining distance, and so on ad infinitum. Since this process involves completing an infinite number of tasks in a finite amount of time, Zeno argues that motion is logically impossible. Similarly, the Achilles and the tortoise paradox suggests that even a faster runner like Achilles can never overtake a slower opponent if the latter has a head start. Each time Achilles reaches the tortoise's previous position, the tortoise has advanced slightly further, creating an endless sequence of diminishing gaps that seemingly prevent Achilles from ever closing the distance. These paradoxes appear irrational when juxtaposed with our sensory experiences. After all, we move through space effortlessly every day, and runners routinely overtake one another without issue. Yet, Zeno's arguments expose fundamental ambiguities in our concepts of divisibility and continuity. For centuries, ancient mathematicians struggled to resolve these contradictions, lacking the sophisticated tools of modern calculus and physics. Without a framework to reconcile the infinite with the finite, Zeno's paradoxes stood as insurmountable challenges to the coherence of motion and change. Today, however, we possess the mathematical language to address these enigmas. The advent of calculus in the 17th century provided a powerful tool for understanding infinite series and their convergence to finite values. For instance, the sum of an infinite geometric series, such as halving distances in the dichotomy paradox, can yield a finite result, demonstrating that infinite processes need not imply impossibility. Modern physics further refines our comprehension of motion, showing that space and time are not infinitely divisible, but instead quantized at the smallest scales. These developments offer a resolution to Zeno's paradoxes, yet their philosophical implications endure, inviting deeper reflection on the nature of reality and human cognition. The enduring power of Zeno's paradoxes lies in their ability to highlight the gap between abstract mathematics and tangible experience. While equations and formulas can describe the mechanics of motion with remarkable precision, they often fail to capture its intuitive essence. Our sensory perception tells us that movement is smooth and uninterrupted, yet Zeno's arguments suggest otherwise, fracturing motion into an infinite cascade of discrete steps. This discrepancy underscores the complexity of reconciling theoretical models with lived reality, reminding us that scientific descriptions, no matter how elegant, may never fully encapsulate the richness of human experience. Philosophically, Zeno's paradoxes invite reflection on the nature of infinity itself. Is infinity merely a useful construct, a conceptual tool employed by mathematicians and physicists, or does it represent something fundamentally unknowable? Can we ever fully grasp the infinite, or are we forever constrained by the limitations of finite minds? These questions resonate deeply with humanity's ongoing quest to understand the cosmos, from the infinitesimal scale of subatomic particles to the boundless expanse of the universe. Infinity serves as both a mirror and a magnifying glass, reflecting our deepest aspirations while amplifying the mysteries that define our existence. Moreover, Zeno's paradoxes challenge us to reconsider the nature of time and space. If space is infinitely divisible, then motion becomes an illusion, a series of static snapshots strung together to create the appearance of fluidity. Conversely, if space and time are quantized, as quantum mechanics suggests, then Zeno's arguments lose their logical force, replaced by a discrete framework that aligns more closely with physical reality. This tension between continuity and discreteness mirrors broader debates in philosophy and science, highlighting the provisional nature of our understanding and the ever-evolving dialogue between theory and observation. Scientifically, Zeno's paradoxes continue to inspire inquiry into the foundations of physics and mathematics. Concepts like quantum mechanics and relativity challenge traditional notions of continuity, suggesting that space and time may not be as smooth or uniform as they appear. In quantum mechanics, particles do not follow continuous trajectories, but instead exist as probabilistic waves until measured. Similarly, Einstein's theory of relativity reveals that time is not absolute but relative, shaped by factors like velocity and gravity. By probing these boundaries, researchers aim to uncover deeper truths about the fabric of reality, pushing the limits of what we know and challenging us to rethink the very nature of existence. Ethically, Zeno's paradoxes raise intriguing questions about decision-making and responsibility. If motion is an illusion, then action itself becomes suspect, raising doubts about agency, free will, and the consequences of our choices. How can we act meaningfully in a world where progress is perpetually deferred, divided into an infinite sequence of incomplete tasks? These considerations echo contemporary debates surrounding artificial intelligence and automation, where decisions made by machines often involve complex calculations that defy human intuition. By engaging with Zeno's paradoxes, we cultivate a mindset of critical thinking and humility, recognizing the fragility of our assumptions and the importance of questioning the status quo. Culturally, Zeno's paradoxes have left an indelible mark on literature, art, and popular imagination. They appear in works ranging from Jorge Luis Borges' labyrinthine narratives to Christopher Nolan's mind-bending films, often used to explore themes of infinity, recursion, and the limits of knowledge. Visual artists have depicted the paradoxes through fragmented compositions, recursive patterns, and optical illusions, capturing the disorienting interplay between order and chaos. By engaging with Zeno's ideas through creative expression, audiences gain a deeper appreciation for their complexity, transforming abstract concepts into emotionally resonant experiences. Ultimately, Zeno's paradoxes serve as both a mirror and a magnifying glass, reflecting our deepest fears and aspirations while amplifying the mysteries that define our existence. They remind us of the sheer audacity of human curiosity, the fact that we, fragile creatures born of stardust, dare to ask such monumental questions in the first place. And they challenge us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Whether viewed through the lens of rigorous academic inquiry or philosophical contemplation, the paradoxes underscore the boundless potential of thought itself. From the infinite to the immediate, let's turn our attention to a moral dilemma that tests the limits of ethics and decision-making. The trolley problem. When faced with impossible choices, how do we determine right from wrong? prepare to confront the weight of responsibility next. The trolley problem. To grapple with the trolley problem is to confront one of the most enduring and unsettling dilemmas in moral philosophy. This thought experiment, though deceptively simple, forces us to navigate the treacherous waters of ethical decision-making, exposing the complexities and contradictions inherent in human morality. At its core, the trolley problem presents a stark choice between two competing ethical frameworks: utilitarianism, which seeks the greatest good for the greatest number, and deontological ethics, which prioritizes adherence to moral rules regardless of outcomes. In its simplest form, the dilemma asks whether it is morally permissible to actively cause harm to one person in order to save multiple others. While the scenario seems straightforward, its implications ripple outward, challenging not only our understanding of right and wrong, but also the very nature of humanity itself. Imagine yourself standing beside a railway switch as a runaway trolley hurtles toward 5 unsuspecting workers tied to the tracks. You have the power to pull a lever, diverting the trolley onto another track, but doing so will kill a single individual standing there instead. What do? This harrowing question lies at the heart of the trolley problem, probing the depths of our moral reasoning. Should we judge actions by their intentions or their consequences? Is it acceptable to take a life to save others, or does the act of killing inherently violate a sacred principle? These questions defy easy answers, revealing the ambiguity and subjectivity that underpin moral judgments. Despite its simplicity, the trolley problem exposes profound tensions in ethical theory. Utilitarianism, championed by philosophers like Jeremy Bentham and John Stuart Mill, argues that the morality of an action should be judged solely by its outcomes. From this perspective, pulling the lever is the clear choice. It minimizes harm by sacrificing one life to save 5. However, deontological ethics, rooted in the work of Immanuel Kant, insists that certain actions are inherently right or wrong, irrespective of their consequences. According to this framework, taking a life, even to save others, is morally impermissible because it violates a fundamental duty to respect human dignity. The clash between these two approaches creates a philosophical impasse, forcing us to confront the limits of universal principles and the context-dependent nature of morality. Variations of the trolley problem introduce additional layers of complexity, further complicating our moral calculus. Consider a scenario where you must push a large individual off a bridge to stop the trolley, saving the 5 workers below. Unlike pulling a lever, this action requires direct physical involvement, making the act of killing more visceral and immediate. Studies show that people are far less likely to intervene in this version of the dilemma, even though the outcome, saving 5 lives at the cost of 1, remains identical. This discrepancy underscores the role of emotion and intuition in moral reasoning, suggesting that our decisions are influenced not only by logic, but also by psychological factors such as personal proximity, emotional attachment, and cognitive biases. The implications of the trolley problem extend far beyond academic philosophy, resonating deeply in fields as diverse as law, medicine, and artificial intelligence. For example, autonomous vehicles must navigate similar dilemmas when faced with unavoidable collisions. Should they prioritize the safety of passengers, pedestrians, or bystanders? How should engineers program machines to make ethical decisions, especially when human lives hang in the balance? These scenarios highlight the difficulty of translating abstract moral theories into practical applications, underscoring the need for interdisciplinary collaboration and rigorous ethical inquiry. In medicine, the trolley problem finds echoes in debates surrounding resource allocation and triage. During emergencies, healthcare professionals often face impossible choices about who receives life-saving treatment and who does not. Should scarce resources be distributed based on utilitarian principles, maximizing the number of lives saved? Or should they adhere to deontological ethics, ensuring equitable treatment regardless of outcomes? These questions become even more pressing in the context of global crises, such as pandemics or natural disasters, where the stakes are immeasurably high and the margin for error vanishingly small. Philosophically, the trolley problem challenges us to reconcile competing ethical frameworks, revealing the limitations of universal principles and the context-dependent nature of moral decisions. It invites reflection on the role of empathy, critical thinking, and cultural influences in shaping our values. For instance, studies conducted across different societies reveal significant variations in how people respond to the dilemma, suggesting that morality is not an objective truth, but a dynamic interplay of emotions, traditions, and social norms. By engaging with the trolley problem, we cultivate a deeper appreciation for the complexities of human behavior, recognizing that ethical dilemmas rarely yield clear-cut solutions. Moreover, the trolley problem serves as a powerful reminder of the fragility of human existence. Each variation of the dilemma forces us to confront the weight of responsibility, inviting reflection on what it means to be accountable for our actions. Whether pulling a lever, pushing someone off a bridge, or refusing to intervene altogether, every choice carries profound consequences, not only for those directly affected, but also for ourselves as moral agents. These considerations blur the line between action and inaction, raising troubling questions about complicity, guilt, and redemption. Scientifically, the trolley problem has inspired groundbreaking research into the neurobiology of moral decision-making. Functional MRI studies reveal that different regions of the brain are activated depending on the nature of the dilemma, with emotional responses dominating in scenarios involving personal involvement and logical reasoning prevailing in more detached situations. These findings suggest that morality is not a monolithic construct, but a multifaceted phenomenon, shaped by both biological and environmental factors. By probing these boundaries, researchers aim to uncover deeper truths about the origins of human ethics and the evolutionary pressures that have shaped our capacity for cooperation and altruism. Culturally, the trolley problem has permeated literature, film, and popular imagination, serving as a lens through which society examines its collective anxieties and aspirations. It appears in works ranging from dystopian novels to courtroom dramas, often used to explore themes of justice, sacrifice, and the limits of power. Visual artists have depicted the dilemma through fragmented compositions, recursive patterns, and optical illusions, capturing the disorienting interplay between order and chaos. By engaging with the trolley problem through creative expression, audiences gain a deeper appreciation for its complexity, transforming abstract concepts into emotionally resonant experiences. Ultimately, the trolley problem serves as both a mirror and a magnifying glass, reflecting our deepest fears and aspirations while amplifying the mysteries that define our existence. It reminds us of the sheer audacity of human curiosity, the fact that we, fragile creatures born of stardust, dare to ask such monumental questions in the first place. And it challenges us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Whether viewed through the lens of rigorous academic inquiry or philosophical contemplation, the paradox underscores the boundless potential of thought itself. From moral quandaries to relativistic conundrums, let's explore a paradox that bends the very fabric of time and space, the twin paradox. How can two people age at different rates despite sharing the same origin? Prepare to unravel the mysteries of relativity next. The twin paradox. To explore the twin paradox is to embark on a journey that defies our most fundamental intuitions about time, space, and existence. At its core, this paradox arises from the revolutionary insights of Albert Einstein's theory of relativity, which fundamentally altered humanity's understanding of the universe. According to Einstein's equations, time is not an absolute constant, but a flexible dimension influenced by factors such as velocity and gravity. This realization gives rise to one of the most intriguing implications of special relativity, the phenomenon of time dilation. Imagine two identical twins, one of whom embarks on a high-speed journey through space while the other remains on Earth. Upon returning, the traveling twin discovers they have aged less than their sibling, a consequence of relativistic effects that stretch the fabric of time itself. While the mathematics behind this paradox is well established, its philosophical and existential implications challenge us to rethink the very nature of reality. The twin paradox arises from the interplay between special relativity and acceleration. Special relativity posits that time slows down for objects moving at near-light speeds relative to stationary observers. For the traveling twin, this means that their journey through space occurs over a shorter duration in their personal frame of reference compared to the stay-at-home twins' experience of time on Earth. Critics initially argued that this created a logical inconsistency. If both twins view themselves as stationary, a valid assumption under the principles of relativity, why should one age faster than the other? The resolution lies in recognizing that the traveling twin undergoes acceleration and deceleration during their voyage, breaking the symmetry of their reference frames. This asymmetry ensures that only the traveling twin experiences the full effects of time dilation, resolving the apparent paradox. While the mathematics behind the twin paradox is robust and supported by decades of experimental evidence, its practical applications remain speculative. However, experiments involving atomic clocks flown on airplanes have confirmed time dilation effects, lending credence to the theory. In one famous experiment, physicists synchronized highly precise atomic clocks and placed one aboard a jet aircraft while keeping another on the ground. After the flight, the airborne clock was found to have ticked slightly slower than its stationary counterpart, a difference so minute yet undeniable that it aligned perfectly with Einstein's predictions. These findings reinforce the counterintuitive yet undeniable reality of relativistic physics, bridging the gap between abstract theory and tangible observation. The twin paradox challenges our intuitive understanding of time as a linear progression. From a young age, we are taught to perceive time as a universal constant, a steady march forward that governs the rhythms of life. Yet, Einstein's theories reveal that time is malleable, shaped by factors like velocity and gravitational fields. This realization has profound implications for space exploration, suggesting that astronauts traveling at relativistic speeds could return to Earth centuries after their departure, effectively stepping into the distant future. Such scenarios blur the line between science fiction and scientific possibility, inviting reflection on humanity's place within the vast expanse of cosmic history. Philosophically, the twin paradox invites deep contemplation on the nature of aging and mortality. If time is relative, what does it mean to grow old? Does the subjective experience of time differ from its objective measurement? Consider the traveling twin, who returns to find their sibling aged significantly more than themselves. To the traveling twin, their journey may have felt brief, a matter of years or even months. Yet, to the stay-at-home twin, decades may have passed. This discrepancy raises troubling questions about the relationship between perception and reality. Is aging merely a biological process governed by the passage of time, or does it encompass something deeper, an accumulation of memories, experiences, and relationships? These considerations blur the line between science and metaphysics, inspiring contemplation about the human condition and our relationship with time. Moreover, the twin paradox forces us to confront the fragility of human identity. If two individuals can experience time so differently, what does it mean to share a common existence? Are we defined by the moments we live through, or by the connections we forge with others? These questions resonate deeply with humanity's ongoing quest to understand the cosmos, from the infinitesimal scale of subatomic particles to the boundless expanse of the universe. They remind us that our understanding of reality is always provisional, shaped by the limitations of our senses and intellect. Scientifically, the twin paradox underscores the elegance and complexity of Einstein's theories. It serves as a reminder of the revolutionary insights gained through rigorous inquiry, transforming our understanding of the universe and our place within it. Concepts like time dilation and length contraction challenge traditional notions of continuity, suggesting that space and time are not fixed, but dynamic dimensions shaped by motion and energy. By probing these boundaries, researchers aim to uncover deeper truths about the fabric of reality, pushing the limits of what we know and challenging us to rethink the very nature of existence. Ethically, the twin paradox raises intriguing questions about responsibility and fairness. If time is relative, how do we measure accountability across vastly different temporal scales? Consider a scenario where a space traveler returns to Earth centuries later, only to find that their actions or inactions have unforeseen consequences for future generations. Should they be held responsible for outcomes they could not have anticipated? These considerations echo contemporary debates surrounding climate change and long-term decision-making, where the weight of responsibility extends far beyond individual lifetimes. Culturally, the twin paradox has left an indelible mark on literature, art, and popular imagination. It appears in works ranging from science fiction novels to philosophical treatises, often used to explore themes of time, memory, and identity. Visual artists have depicted the paradox through fragmented compositions, recursive patterns, and optical illusions, capturing the disorienting interplay between order and chaos. By engaging with the twin paradox through creative expression, audiences gain a deeper appreciation for its complexity, transforming abstract concepts into emotionally resonant experiences. Ultimately, the twin paradox serves as both a mirror and a magnifying glass, reflecting our deepest fears and aspirations while amplifying the mysteries that define our existence. It reminds us of the sheer audacity of human curiosity, the fact that we, fragile creatures born of stardust, dare to ask such monumental questions in the first place. And it challenges us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Whether viewed through the lens of rigorous academic inquiry or philosophical contemplation, the paradox underscores the boundless potential of thought itself. From the elasticity of time to the persistence of identity, let's examine a paradox that questions the essence of selfhood: the ship of Theseus. When does an object cease to be itself? Prepare to ponder the boundaries of identity next. The ship of Theseus. To grapple with the ship of Theseus is to embark on a philosophical journey that transcends the boundaries of time, identity, and transformation. This ancient paradox, rooted in Greek legend, challenges us to question the very essence of what it means for something or someone to remain itself amidst constant change. Imagine a ship whose wooden planks are gradually replaced over time until none of the original material remains. Is it still the same ship? Now, imagine reassembling the discarded planks into a replica. Which vessel, if either, is the true ship of Theseus? At its heart, this thought experiment probes the nature of identity, continuity, and transformation, inviting reflection on how objects, people, and even ideas persist despite, or perhaps because of, their evolution. The origins of the ship of Theseus lie in the mythological preservation of a hero's legacy. According to legend, the ship used by Theseus, a celebrated figure in Greek mythology, was meticulously maintained by replacing its decaying parts. Philosophers later adopted this story as a lens through which to interrogate the concept of identity. At its core lies a profound tension between sameness and change. If every component of an object is altered, does it retain its original essence? Conversely, if the old components are reassembled, does the new configuration constitute a separate entity? These questions force us to confront the fragility of permanence and the fluidity of existence. The paradox extends far beyond physical objects, resonating deeply with broader ideas of selfhood and continuity. Consider the human body, which undergoes constant regeneration, replacing nearly all its cells approximately every 7 years. Are we still the same person we were a decade ago, or have we become someone entirely new? Similarly, institutions, traditions, and even nations evolve over time, raising questions about whether their essence persists despite changes in form or function. For instance, a centuries-old university may modernize its curriculum and infrastructure while claiming to embody the same spirit that defined its founding. But at what point does such transformation render it unrecognizable? These considerations blur the line between science and metaphysics, inspiring contemplation about the human condition and our relationship with change. Philosophically, the ship of Theseus invites reflection on the nature of permanence and impermanence. It reminds us that identity is not fixed but fluid, shaped by experiences, choices, and transformations over time. This insight resonates deeply with existential philosophy, which emphasizes the dynamic and evolving nature of the self. Thinkers like Jean-Paul Sartre and Martin Heidegger have explored similar themes, arguing that existence is inherently unstable, defined by perpetual becoming rather than static being. By engaging with the ship of Theseus, we cultivate a deeper appreciation for the complexities of human experience, recognizing that identity is less a rigid structure and more a living tapestry woven from memory, intention, and adaptation. Scientifically, the paradox parallels debates in fields like biology and psychology. Researchers studying cellular regeneration grapple with similar questions about continuity and change. For example, stem cell therapy raises ethical and practical concerns about whether altering an organism's biological composition compromises its identity. In psychology, studies on memory and personality suggest that individuals are constantly reshaping their sense of self through interactions with their environment. These intersections highlight the interconnectedness of matter, mind, and meaning, offering a richer understanding of how we define and redefine ourselves over time. The implications of the ship of Theseus challenge our intuitive understanding of identity, forcing us to confront the fragility of permanence. If an object or person can change so drastically yet still be considered the same, what truly defines their essence? Is it physical composition, functional purpose, or something more abstract, like memory or intention? These uncertainties blur the line between science and metaphysics, inspiring contemplation about the human condition and our relationship with change. For instance, consider a restored artifact in a museum. If its original materials have been replaced, is it still authentic? What about digital files or cultural traditions that evolve over generations? These considerations echo debates surrounding artificial intelligence, cloning, and the preservation of heritage, reminding us that identity is both personal and collective. Moreover, the paradox raises ethical and practical questions about authenticity and ownership. In art restoration, for example, practitioners must balance preserving an object's historical integrity with ensuring its longevity. A painting restored with modern techniques may no longer reflect the artist's original intent, yet discarding it altogether risks erasing its cultural significance. Similarly, debates about cloning and genetic engineering force us to reconsider what constitutes individuality. If a clone shares identical DNA with its progenitor, are they the same person? Or do their distinct experiences create a divergence in identity? These dilemmas underscore the complexity of defining essence in a world where change is inevitable. Culturally, the ship of Theseus has permeated literature, film, and art, often used to explore themes of transformation, legacy, and renewal. Writers like Jorge Luis Borges and Italo Calvino have employed the paradox to examine the interplay between stability and flux, crafting narratives that blur the boundaries of reality and imagination. Filmmakers have depicted the paradox through fragmented compositions, recursive patterns, and optical illusions, capturing the disorienting interplay between continuity and disruption. Visual artists, meanwhile, use the motif of reconstruction to evoke the tension between preservation and innovation. By engaging with the paradox through creative expression, audiences gain a deeper appreciation for its complexity, transforming abstract concepts into emotionally resonant experiences. Ultimately, the ship of Theseus serves as both a mirror and a magnifying glass, reflecting our deepest fears and aspirations while amplifying the mysteries that define our existence. It reminds us of the sheer audacity of human curiosity, the fact that we, fragile creatures born of stardust, dare to ask such monumental questions in the first place. And it challenges us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Whether viewed through the lens of rigorous academic inquiry or philosophical contemplation, the paradox underscores the boundless potential of thought itself. From the persistence of identity to the darkness of the cosmos, let's delve into a paradox that questions the very nature of light and infinity. Olber's paradox. Why isn't the night sky uniformly bright if the universe is infinite? Prepare to unravel the mysteries of the stars next. Olber's paradox. To gaze up at the night sky is to confront one of the most profound mysteries in human experience, its darkness. At first glance, this observation might seem mundane. After all, we are accustomed to the velvet expanse of stars punctuated by vast stretches of emptiness. Yet, when we pause to consider the implications of this darkness, we uncover a paradox that has puzzled astronomers and philosophers for centuries. Known as Olber's paradox, this enigma challenges our assumptions about the universe's structure, age, and ultimate fate. It forces us to question why, if the cosmos is infinite and filled with countless stars, the night sky isn't uniformly bright. The answer lies not only in the physical properties of light and space, but also in the dynamic and evolving nature of the universe itself, a revelation that reshapes our understanding of existence. Olber's paradox arises from a seemingly straightforward assumption that the universe is infinite, static, and populated by stars distributed evenly throughout space. If this were true, then every line of sight would eventually intersect with the surface of a star, making the night sky as luminous as the sun. Imagine standing in a dense forest where trees stretch infinitely in all directions. No matter which way you look, your gaze would always meet the trunk of a tree. Similarly, in an infinite and unchanging universe, the cumulative light from countless stars should render the night sky ablaze with brilliance. Yet, the darkness we observe contradicts this expectation, revealing fundamental flaws in our assumptions about the cosmos. Modern cosmology provides several explanations for resolving the paradox, each shedding light on the intricate workings of the universe. One key factor is the finite age of the cosmos. Since light travels at a fixed speed, we can only observe stars whose light has had enough time to reach us since the universe's inception. Beyond a certain horizon, known as the observable universe, the light from distant stars and galaxies remains invisible because it has not yet traversed the immense distances separating them from Earth. This temporal limitation underscores the youth of the universe, which is approximately 13.8 billion years old according to the Big Bang Theory. Thus, the darkness of the night sky serves as a testament to the finite nature of cosmic history, reminding us that we inhabit a universe still in its infancy. Another crucial factor is the expansion of the universe, a phenomenon first proposed by Edwin Hubble in the early 20th century, and later corroborated by observations of galaxy redshifts. As space itself expands, the wavelength of light emitted by distant stars stretches, shifting it out of the visible spectrum and into the infrared or even radio wavelengths. This process, known as cosmological redshift, renders much of the light from faraway galaxies undetectable to the naked eye. Consequently, the night sky appears darker than it would in a static universe, where light could travel unimpeded across infinite distances without alteration. The expanding universe thus acts as a veil, concealing the full radiance of the cosmos and preserving the illusion of emptiness. A third contributing factor involves the absorption and scattering of light by interstellar dust and gas. Initially, one might assume that these materials could account for the darkness of the night sky by blocking or diffusing stellar radiation. However, further analysis reveals that such an explanation falls short. Over time, interstellar matter would absorb sufficient energy to heat up and re-emit radiation, effectively negating its obscuring effect. Therefore, while dust and gas play a role in shaping our view of the universe, they cannot fully resolve Olber's paradox. Instead, the resolution lies primarily in the dynamic and evolving nature of the cosmos, a universe that is neither static nor infinite, but instead expanding and transforming over time. The implications of Olber's paradox extend far beyond its immediate astronomical context, forcing us to confront profound questions about the origins, structure, and ultimate fate of the universe. The paradox serves as a gateway to understanding modern cosmological theories, including the Big Bang, the expansion of space, and the mysterious presence of dark matter and dark energy. For instance, the discovery of cosmic microwave background radiation, a faint glow left over from the universe's fiery birth, provides compelling evidence for the Big Bang theory, reinforcing the idea that the cosmos had a beginning rather than existing eternally in a steady state. Similarly, observations of galaxy redshifts reveal that the universe is not only expanding, but doing so at an accelerating rate, driven by an enigmatic force known as dark energy. These revelations challenge our intuitive notions of reality, inviting reflection on the limits of human perception and the vastness of the unknown. Philosophically, Olber's paradox invites contemplation on the fragility of existence and the impermanence of light. The darkness of the night sky symbolizes the boundaries of our knowledge, challenging us to find inspiration in the mysteries that lie beyond. It reminds us that the photons reaching our eyes may have embarked on their journey millions or even billions of years ago, offering a fleeting glimpse into the distant past. In this sense, the night sky becomes a time capsule, preserving fragments of cosmic history that transcend the ephemeral nature of human life. Moreover, the paradox underscores the interconnectedness of all things, highlighting how our understanding of the universe is shaped by both its physical properties and our subjective experience of it. Scientifically, Olber's paradox has inspired groundbreaking research into the origins and evolution of the universe. Observations of large-scale structures, such as galaxy filaments and voids, provide insights into the distribution of matter and energy across cosmic scales. Studies of primordial fluctuations in the cosmic microwave background radiation offer clues about the conditions present mere fractions of a second after the Big Bang. By probing these frontiers, researchers aim to uncover deeper truths about the fabric of reality, pushing the limits of what we know and challenging us to rethink the very nature of existence. Each discovery brings us closer to answering humanity's oldest questions. Where did we come from? What is our place in the cosmos? And what lies ahead? Culturally, Olber's paradox has left an indelible mark on literature, art, and popular imagination. It appears in works ranging from science fiction novels to philosophical treatises, often used to explore themes of infinity, mystery, and a human desire to comprehend the incomprehensible. Writers like H.P. Lovecraft and Arthur C. Clarke have employed the paradox to evoke the awe-inspiring vastness of the universe, crafting narratives that blur the boundaries between wonder and terror. Visual artists depict the paradox through vast expanses of darkness punctuated by faint pinpricks of light, capturing the delicate balance between emptiness and illumination. Musicians and filmmakers, too, draw inspiration from the paradox, using it as a metaphor for the search for meaning amidst uncertainty. By engaging with the paradox through creative expression, audiences gain a deeper appreciation for its complexity, transforming abstract concepts into emotionally resonant experiences. Ultimately, Olber's paradox serves as both a mirror and a magnifying glass, reflecting our deepest fears and aspirations while amplifying the mysteries that define our existence. It reminds us of the sheer audacity of human curiosity, the fact that we, fragile creatures born of stardust, dare to ask such monumental questions in the first place. And it challenges us to find inspiration in the unknown, to marvel at the mysteries that lie just beyond the horizon of understanding. Whether viewed through the lens of rigorous academic inquiry or philosophical contemplation, the paradox underscores the boundless potential of thought itself. From the darkness of the cosmos to the persistence of hope, let's conclude our journey with a reflection on humanity's enduring quest for meaning. Whether confronting the vastness of space or the depths of the human soul, we find solace in the act of questioning itself. Let's embrace the beauty of uncertainty as we bring this exploration to a close. Finding peace amidst paradox. To conclude our journey through the labyrinth of paradoxes, we arrive at a profound realization. Perhaps the purpose of these enigmatic riddles is not to resolve them, but to embrace their ambiguity. Paradoxes, by their very nature, defy easy answers, challenging us to stretch the boundaries of thought and perception. They remind us that the universe, and indeed existence itself, is far too intricate to be confined within the rigid structures of logic or language. Rather than seeking closure, we might instead find value in the act of questioning, allowing paradoxes to inspire curiosity, humility, and a deeper appreciation for the infinite complexity of life. At its core, the concept of living with paradox invites us to reframe how we approach uncertainty. Human beings have an innate desire for clarity and resolution. We crave order amidst chaos, certainty amidst doubt. Yet, paradoxes reveal that life rarely conforms to such tidy categories. Instead, they expose the fluidity of truth, the interconnectedness of opposites, and the beauty of contradictions. By embracing ambiguity, we open ourselves to new perspectives and possibilities, cultivating a mindset that thrives not on finality, but on exploration. In doing so, we honor the dynamic, ever-evolving nature of existence. Consider the paradoxes we have explored thus far. From the malleability of time in the twin paradox to the fragility of identity in the ship of Theseus, each one challenges our assumptions about reality. These thought experiments do not offer definitive solutions, but rather serve as mirrors reflecting the complexities of the human condition. They teach us that understanding is not always about finding answers, but about learning to live with questions, about accepting that some mysteries may forever elude our grasp. This acceptance does not diminish our pursuit of knowledge. Rather, it enriches it, transforming inquiry into an act of wonder and reverence. Living with paradox means recognizing uncertainty as an intrinsic part of the human experience. It is the tension between opposing forces, order and chaos, permanence and impermanence, light and darkness, that gives life its depth and texture. To deny this tension is to resist the very essence of what it means to be alive. Instead, by leaning into the discomfort of paradox, we discover a kind of liberation. We learn to find peace amidst chaos, solace in curiosity, and joy in discovery. Each paradox becomes a doorway to greater awareness, inviting us to see the world not as a collection of absolutes, but as a tapestry woven from countless threads of possibility. Philosophically, this perspective aligns with existentialist thought, which emphasizes the importance of creating meaning in a seemingly indifferent universe. Thinkers like Albert Camus and Søren Kierkegaard grappled with the absurd, the inherent conflict between humanity's search for meaning and the universe's apparent silence. For Camus, the answer lay not in despair, but in defiance, in embracing the absurd and continuing to seek purpose despite its elusiveness. Similarly, by embracing paradox, we affirm our agency in the face of uncertainty. We choose to engage with the unknown not out of obligation, but out of love, for the process of discovery, for the beauty of mystery, and for the sheer audacity of being. Scientifically, the embrace of paradox has driven some of humanity's greatest breakthroughs. Quantum mechanics, for instance, thrives on contradiction, revealing a subatomic world where particles can exist in multiple states simultaneously and where observation itself alters reality. The theory defies classical intuition, yet provides unparalleled insights into the workings of the cosmos. Likewise, Einstein's theory of relativity overturned centuries of Newtonian physics by demonstrating that space and time are not fixed, but relative, a revelation that initially seemed paradoxical, yet ultimately transformed our understanding of the universe. These examples underscore the power of paradox as a catalyst for innovation, reminding us that progress often arises from embracing, not rejecting, the unfamiliar. Culturally, paradoxes permeate art, literature, and mythology, serving as potent symbols of the human condition. Consider the ancient symbol of the Ouroboros, a serpent devouring its own tail, which represents the cyclical nature of existence and the unity of opposites. Similarly, the yin-yang of Taoist philosophy illustrates how seemingly contradictory forces coexist and complement one another. These archetypes resonate deeply because they reflect universal truths about balance, transformation, and interconnectedness. By engaging with paradox through creative expression, we tap into a shared wellspring of wisdom, connecting across time and space with others who have wrestled with the same enduring questions. On a personal level, embracing paradox fosters resilience and adaptability. Life is inherently unpredictable, filled with moments of joy and sorrow, triumph and loss. To navigate this terrain requires a willingness to hold conflicting emotions in tandem, to grieve while still finding gratitude, to feel fear while pursuing courage. Paradox teaches us that opposing states are not mutually exclusive, but rather two sides of the same coin. By integrating these dualities, we cultivate emotional intelligence, deepening our capacity for empathy and self-awareness. This integration allows us to move through life with greater grace, embracing its complexities without becoming overwhelmed by them. Moreover, paradox serves as a reminder of our place within the grander scheme of things. The vastness of the cosmos dwarfs individual human concerns, yet within that immensity lies the extraordinary gift of consciousness, the ability to ponder, to dream, to create. This duality humbles us even as it empowers us, grounding our aspirations in a sense of awe and responsibility. By acknowledging both our insignificance and our significance, we strike a delicate balance between humility and purpose. We recognize that while we may never fully understand the universe, our efforts to do so contribute to something far greater than ourselves. In embracing paradox, we also find a path toward inner peace. The relentless pursuit of certainty can lead to frustration and disillusionment, as we inevitably encounter limits to our knowledge. By contrast, accepting uncertainty frees us from the burden of needing to know everything. It invites us to dwell in the present moment, savoring the richness of experience without clinging to outcomes. This shift in perspective transforms anxiety into curiosity, fear into fascination, and stagnation into growth. It allows us to find beauty in the unfinished, the unresolved, and the unknowable. Ultimately, living with paradox is an act of faith, not in the religious sense, but in the broader belief that life is worth exploring precisely because it resists easy categorization. It is a celebration of the infinite complexity of existence, a testament to the boundless potential of thought, and a tribute to the enduring spirit of inquiry. By embracing paradox, we affirm our humanity, honoring the interplay of light and shadow, clarity and mystery that defines the human journey. We come to see that the answers we seek are not endpoints, but stepping stones, leading us ever onward into uncharted territories of understanding. As we bring this exploration to a close, let us carry these insights with us, not as burdens, but as gifts. Paradoxes remind us that life is not a puzzle to be solved, but a story to be lived, rich with nuance and wonder. They invite us to remain curious, to cherish the act of questioning, and to find joy in the endless horizons of possibility. In doing so, we honor not only the complexity of the universe, but also the depth of our own humanity. Thank you for joining me on this mind-expanding adventure. As you drift off to sleep, let these paradoxes linger softly in your thoughts, inviting dreams of endless horizons and untold wonders. Good night.